Okay, good afternoon. Welcome back. So last class we discussed about the contiguous and non-contiguous memory allocation. So basically in the contiguous memory allocation method, memory is divided into two partitions. One is the resident operating system and in the lower part and user process in the upper part. So what about the contiguous memory allocation? Let's take an example. Suppose you have to declare an array. Array is a contiguous memory allocation. Suppose you have to create the student of the student database of one college. So you want to declare an array system in the array of size of, suppose you don't know how many students will admitted in that college in this year. Then you have to create a database. Suppose the total capacity of the intake of that college is suppose 400. So definitely you have to create the either 400 or 50 or 100 location extra. So suppose you have to create a 450 location, that means int a 450 size of the array you have to declare. But unfortunately in that year the number of the student admitted is just 250. That means in that case you have allocated is a 450 location, but 250 is only filled up, and whatever the rest 200, because this 200 space is not allocated to other process by the memory, because according to the architecture, once one memory space is allocated to particular process, unnecessary it is not released by another process, the same process, it will not be allocated to the other process. That means this is simply, it is a wastage concept, right? So that is the methods of contiguous memory allocation. It is a fixed size partition, fixed maximum number of process, fixed maximum process size. Then this is type of phenomena. But in case of the non-contiguous memory allocation, it is basically a method on the contrary to contiguous allocation. Allocates the memory space present in different location to the process as per its requirement. Suppose you have to require 200, that means the location is created as your requirement, right? And that means your 250 students is filled up this year, that means the location is 250 is created. This will be created dynamically one by one, and that memory space are created in the randomly, that means in the different location of the process. As all the variables memory space is in distributed pattern, so the freely available memory space is also scattered here and there. So in the non-contiguous memory allocation model, several non-adjacent memory areas are allocated to a process. So none of these areas is large enough to hold the complete process. Hence, a part of the process is loaded in each of these areas. So, next is your multiple partition allocation. In the multiple partition allocation, what is the multiple partition allocation, there are different terms. First is a whole, a block of available memory. Holes of various size are scattered throughout the memory. It is a free space. That means that space is not used. That is a free space, and that space is known as the hole, is created within that memory. When a process arrives, it is allocated memory from a hole large enough to accommodate it. Operating system maintains information about allocated and free partition. That means whole, allocated partitions and free partitions. Definitely operating system maintains that info. How many holes are created within the memory, how many space is already allocated to that particular, or the two different process. So if set of holes of various size is scattered throughout memory at any given time, when a process arrives and needs memory, the system search the set for a hole that is large enough for the process. That means when a process entered to a system, the system searches the space or space searches the hole which is large enough for this process. Suppose the process needs 10 kilobyte memory space. So the free space or the hole, whatever the holes are available, the system search a best hole which is suitable for that requirement. If the hole is too large, it is split into two. One part is allocated to the arriving process and the other is returned to the set of holes. Right? When a process terminates, it releases its block of memory, which is then placed back in the set of holes. If the new hole is adjacent to other holes, these adjacent holes are merged to form one larger hole. This procedure is a particular instance of the general dynamic storage allocation problem, and which is how to satisfy request of size n from list of free holes. There are many solutions to this problem. The set of holes is searched to determine which hole is best to allocate. So the fast fit, best fit and the worst fit strategy are the most common one used to select a free hole from the set of available holes. Fast fit means allocate the fast hole that is big enough. Fast hole, that is which one is the big, that will be allocated to that process. Best fit means allocate the smallest hole that is big enough, must search entire list and unless orderly by size. Right? Best fit means allocate the smallest hole that is big enough, must search entire list unless ordered by size. Fast fit, which one is the big fast, that will be allocated to that process. So here problem is that suppose the process needs 30 kilobyte memory space, but the whole size is 80 kilobyte space, that will be allocated. Then 30 is used. What about the 50 kilobyte? It is wasted again. So best fit means allocate the smallest hole that is big enough. That means out of the list you have to search which one is the near about 30 kilobyte. Suppose it is the 30 kilobyte memory space is required and there is a hole which is 32 or 33 kilobyte. That should be allocated to that process. Worst fit means allocate the largest hole. Allocate the largest hole. That means which one is the largest, that will be assigned to that thing. So that is the fast fit, best fit and the worst fit system. Again I am repeating, fast fit means allocate the fast hole that is big enough. Suppose there is a list, fast hole, which one is the fast, in orderly, the which one is the fast and that is also the big enough for that requirement, it will be the allocated. Best fit, you have to search entire the list, which one is the suitable for that requirement, then that will be allocated. Worst fit means allocate the largest hole, must also search entire list. Right? So that is the fast fit, best fit and the worst fit. Next come to the very important part, this is the fragmentation. What is fragmentation? The main problem with contiguous allocation is fragmentation. Memory becomes split into many small pieces that cannot be used effectively. Two types of fragmentation are distinguished. One is your internal fragmentation, another one is your external fragmentation. So fragmentation generally occur in the contiguous memory allocation, and memory becomes split into many small pieces that cannot be used effectively. There are a number of small pieces, right? So first come to the internal fragmentation. Internal fragmentation occurs when the system allocates, internal fragmentation, when the system allocates more than the process required and can use. For example, this happens when the size of the address space is increased to the next power of 2 in a body system. That means Allocate memory may be slightly larger than requested memory, and this size difference is memory internal to a partition but not being used. So, this much about today's class. Next class we are going to discuss about fragmentation. Thank you.